Jai Hind everyone, welcome to the class of Antena and wave propagation, and today we will discuss the topic of one of the topic, that is the sky wave propagation, in which we will discuss about the discuss about the structure of the ionosphere, which is the main role, having a main role in the sky wave propagation, and we will find out the derivation for the expression of refractive index of ionosphere. Or clear? Now, my name is Mr. Himanshu Nagpal, Assistant Professor in EC Department of AKGEC, Ghaziabad. So first of all, we will talk about the sky wave propagation. As we know that there are three types, we have discussed about the three types of propagation, that is the space wave propagation, and another subtype of space wave propagation, it is a ground wave propagation, and the third type of wave propagation, that is the sky wave propagation. Clear? So sky wave propagation is the important part of the unit number 5, and it is also one of the radio wave propagation, in which the signal, let's say if I say this is the earth, and when there is no line of sight communication between the transmitter and the receiver, let's say one of the transmitter is here, and this transmitter want to send this signal to the receiver side, and so during the space wave propagation there is a line of sight communication, that transmitter and receiver are on the same line of sight, then the communications take place. But if the transmitter and the receiver are not in the same line of sight communication, in that case we have to, in that case the signal has to travel through using a sky wave propagation. Yeah, and so this is another type of a radio wave propagation, in which the signal transmit from transmitter end and goes to the ionosphere. Let's say this is a ionosphere layer, and the wave will get reflect back by the ionosphere, and this type of propagation is known as the sky wave propagation. So sky wave propagation is mainly take place with the help of take place through the ionosphere, and in ionosphere there is a reflection of EM waves. So first of all we will discuss about the structure of atmosphere, and after the discuss about the structure of atmosphere, we will talk about the structure of the ionosphere, and then we will discuss about we will find out the expression for the refractive index of the ionosphere. Clear? So let's start one by one. So it is a type of radio wave propagation, the wave which propagate through the atmosphere and are reflected back by the ionosphere of earth atmosphere is known as the sky wave propagation. Means the wave propagate through the ionosphere and get reflected back by the ionosphere is called as the sky wave propagation. So this type of wave propagation is generally mainly used for the frequency communication, and it is on 2 to 30 megahertz, means the signal which is ranges from 2 to 30 megahertz signal, that follows what? That follows the sky wave propagation, and above 30 megahertz signal, the signal will travel through the space wave propagation, will follow the space wave propagation concept. So these waves go from the transmitter antenna to the receiver and traveling through a sky. The sky waves are composed of are of practical importance of at medium and high frequency for a very long distance communication. And this sky wave, this propagation is done through a ionosphere. Now see, first of all we'll discuss about the Earth atmosphere. As we know that this is the Earth, and on this Earth, let's say this is the Earth and this is the atmosphere above the Earth. So first of all, the layer which is close to the Earth, this is the layer of the which lies just above the ground, that is known as the troposphere layer. That is known as the troposphere layer. So ground wave propagation, space wave propagations is generally take place through the troposphere layer. After the troposphere layer, there will be a layer that is a stratosphere. Means first of all, troposphere layer will be there, then there will be a stratosphere, after that there is a ionosphere. So the ground wave propagation generally take place through the troposphere layer, and space wave propagation takes place through the troposphere and the stratosphere layer. So this is the layer of the Earth which lies above the troposphere. The bird fly in this region, the airplanes travel in this region, that is a stratosphere. Ozone layer lies also in this region. The ground wave propagation line of sight means that is a space wave propagation. Propagation takes place in this layer, that is a stratosphere layer. And in the troposphere also there is a line of sight communication in the ground wave propagation. Now next one layer that is above the stratosphere layer, that is the ionosphere layer. So this is the upper layer of the Earth atmosphere where ionization takes place. This ionization is the mainly responsible for the bending of light. Is appreciable. The energy radiated by the sun not only heat this region but also produces a positive and negative ions, and these positive negative ions will play a role in the in creating a refractive index of the ionosphere layer. So since the sun is constantly radiates UV rays and air pressure is low, this layer increases ionization of particles. That means, let's say this is the Earth and the sun heat generally will always take place on the what? On this layer. So ionization due to the heat of the sun or heating effect of the sun, ionization will take place here. Means the elements or atoms get molecules will convert into atoms, and these atoms breaks into the ions and electrons. Let's say if I say this is, let's say this is oxygen. In oxygen molecule, this breaks into what? O minus plus में 2 electrons plus 1 electron, and O2 is breaks into twice of O minus plus में 2 electrons or 4 electrons, as we near 2, 6. So you will say here means this molecule is converted into what? Ions, and when this breaks into the ions, there will be a free electrons will also be presence of free electrons in the ionosphere. Means this ionization take place when the ionization take place due to the heating effect of the sun. The atoms breaks into what? Ions and the free electron, and these free electrons is mainly responsible for creating a refractive index of ionosphere. So the waves which are transmitted from the transmitter to the receiver are reflected back from the ionosphere. It consists of several layers of charged particles in altitude from 30 to 250 miles. Means the thickness of ionosphere is ranges from 30 miles to 250 miles. Clear? Such a travel of the wave from the transmitter to the ionosphere and from the there to receiver on earth is known as the skywave propagation. That I have that if this is a transmitter and this transmitter will be send the signal to the receiver through the ionosphere. So this type of wave propagation is known as the skywave propagation. So I will told you this is the earth atmosphere, that is troposphere. Above that of the troposphere that there will be a stratosphere layer, and above that stratosphere there is a layer of that is the ionosphere, which is mainly responsible for the skywave propagation. The next one is the structure of ionosphere. Now this ionosphere is having a range from 30 miles to 250 miles, means thickness of this ionosphere is ranges from 30 to 50 miles, or can be said as a 50 kilometer to 400 kilometer. So this layer is further divided into 4 types, or you can say 4 to 5 layers. 4 layers. First one, this ionosphere is further divided into 5 layers. That is, the first layer is the D layer, and then E layer, and then this is a all it is known as the F layer, and it can be further divided into 2 types, that is F1 layer and another one is the F2 layer. Clear? So the ionosphere is composed of 3 layers, that is known as a D, E and F layer from the lowest to highest level, and this layer, this F layer is further divided into 2 parts, that is F1 the lower layer and the F2 that is the higher layer. The presence or absence of these layers in the atmosphere and their height above the earth varies with the position of the earth. Means the presence of these layers or absence of these layers mainly depends on the position of the earth. Let's say first of all we'll talk about the first layer is that is the D layer. This D layer ranges from what? 50 to 90 kilometer. This D layer ranges from 50 to 90 kilometer, and it is the lowest region of the ionosphere. This layer only exists when there is a sunlight. So this layer has the ability to reflect signal of low frequency, means the signal which is of that is low frequency, that is from 2 to 10 megahertz. D layer is mainly responsible. High frequency pass right through it and are attenuated. Clear? After sunset, D layer disappears because the rapid recombination of ions. Means this layer is presence of this layer only during the daylight, and when there is a night, means absence of sunlight, this D layer absent. Why it is absent? Because there will be a recombination of ions, means ions get recombined with the free electron and makes a atom or molecule. So next one is the E layer. This E layer ranges from what? 90 to 130 kilometer, and this layer is also exists in both the regions, during the sunlight and after the sunlight. But after the sunlight it disappears slowly, means there will be a recombination take place after sunset, but there will be a lesser recombination as compared to the D layer. The rate of ionic recombination in this layer is rather rapid after the sunset, and the layer is almost gone by the midnight. Recombination take place after the sunset, but there is a rate of recombination is less, but by that this layer disappears by the midnight. So this layer has the ability to reflect signal as high as 20 megahertz signal. Clear? So the range, it is valuable for communication ranges up to about 1500 miles. So next one is the next layer, that is the F layer. This F layer ranges from 140 to 400 kilometer, and F2 layer is mainly exposed to what? Sun. So maximum ionization takes place in the F2 layer and then the F1 layer. So the ionization level here in this layer is very high and varies widely during the day. Means the ionization is at this layer is generally close to the sun, so the ionization takes place, and this ionization takes place varies widely during the day. At noon, this portion of the atmosphere is closest to the sun, and the degree of ionization is the maximum during the maximum daylight, that is during the noon. Maximum ionization take place, and since the atmosphere is rarely rectified at these heights, recombination occurs slowly after the sunset. Recombination takes place but slowly. Clear? So after the sunset, these F1 and F2 layers gets recombined and makes a F layer. So this F layer is mainly useful for the transmission of high frequency signal and for the long distance transmission. So now see this one. If I say this signal, this is the earth. If I say this is earth, or just let's say this is earth and this is a transmitter. This transmitter sends the signal to the receiver side and through the ionosphere layer. When you know that there is a bending of light, means the signal, this is a EM wave and this EM wave is exhibit as a what? Light. Clear? So this EM wave goes upward and then reflected back by the ionosphere layer. It means there is some concept will be there that refract, or that totally internally there will be a total internal reflection by the ionosphere. Means when there is a total internal reflection takes place here, you know that when there is a total internal reflection now, when this total internal reflection takes place, it means that there will be a some refractive index of what? Ionosphere, which is responsible for the refraction or total internal reflection of the EM wave, and this EM wave is generally having the same property as of light. And we know that the for the bending of light or for the traveling of light from one medium to another medium, there will be a refractive index concept will be there. So similarly there will be a concept of refractive index of ionosphere layer. So we will find out the expression for the refractive index. So we will find out the expression for the refractive index of the ionosphere layer. So now see, this is the ionosphere layer. Let's say this ionosphere layer during the sun, this ionosphere layer having molecules, and there will be some free electrons will be there during the sun, because ionization take place. When ionization take place, there will have some free electrons. Now see, when signal transmit from earth station to the ionosphere layer, this signal have some electric field, and let's say let at any height in the ionosphere there will be n free electrons. Let's say that this density is n free electrons, per meter cube. Each electron has a charge of E and mass m. So let's say electric field of value equal to E is equal to Em sin omega t volt per meter. Now when this electric field strike with this electron, so the force exerted by the electric field on each electron, force exerted on each electron by electric field will be equal to what? F equal to minus E into E, that is Newton. And let's say these electrons are free and these electron does not collide with each other. Let's say these electron does not collide with each other, then force will be equal to what? Then there will be what? Two types of current will be there. One is the inductive current will be there, and another type of current will produce, that is a capacitive current. Clear? So now see this F equal to m into A. This F will both be equal to each other because the electron will have an instantaneous velocity v meter per second in the direction of opposite to the field. So this F m into A is equal to what? Minus E into E, and this m equal to acceleration was rate of change of electron velocity with respect to time, that is dv by dt, is equal to minus of E into E. Clear? So now see V is what? V is the instantaneous velocity of electron. So this V will be equal to what? This dV will be equal to what? Minus of E into m multiply by dt. So now just you will see here m will be divided by this one. So dV will be equal to what? This one. On integrating dV both side, you will get what? Velocity of electron is equal to plus of E into Em cos omega t upon m omega, and this is mainly responsible for what? Now see this is the velocity. Now there are two types of, when there are free electrons, there are two types of current will be there. One is the inductive current will be produced, and another one is the capacitive current will be produced. This inductive current will produce due to the free moving electrons. So as we know that let n be the number of electrons, so Je means this current due to the current density due to the moving electrons will be equal to what? Means that is due to the inductive current equal to minus of n into E into V ampere per meter square. So now this minus n into E, put the value of V here, V from here, that is equal to Em cos omega t upon m into omega. Clear? So you will get what? Je equal to minus of ne square upon m omega Em cos omega t. This minus shows that inductive current lags behind the electric field, that is E equal to Em sin omega t by the 90 degree. So next current there will be a what? Displacement current, that is you can say that is also capacitive current. So ignoring the presence of these electrons, the ionosphere can also be ionosphere can be considered in the free space. In that case, displacement current will be equal to what? Displacement current is equal to d by, and this is equal to on putting this value E equal to minus d by dt Em sin omega t. On putting this value you will get JD is equal to epsilon naught, sorry, this is epsilon naught, no, this is epsilon naught Em. Why I have put it, this is a actual epsilon, and I have said that ignoring the presence of electrons, it is considered to as a free space, means epsilon will become equal to epsilon naught. This is epsilon naught equal to Em cos omega t, minus minus get. So this displacement current shows, this positive sign shows that it is this displacement current leads the applied current by the 90 degree. Now the total current produced due to the free electrons, that is equal to total current density, that is Jt is equal to current due to the inductive current and due to the capacitive current, that is Jd plus Je is equal to sum of these two, means addition of equation number this and this, you will get Jt is equal to this one. Now see, you will here see that this is equal to what? This is what? This is what? This is a what? This is what? This is equal to the, comparing these two equations, this equation and compare these two equation, equation number this and this, comparing, you will see that this is a what? Permittivity. Clear? Or you can say that this permittivity is equal to epsilon naught minus में n into में e square upon में m omega square. Just take a common epsilon naught equal to, you will get what? Epsilon naught is equal to 1 minus में n e square upon में m omega square epsilon naught. So hence the epsilon r is equal to epsilon by epsilon 1 minus n e square by m omega square epsilon. So you will get the refractive index of ionosphere with equal to, so as this is a permittivity of, relative permittivity of what? Ionosphere, that is equal to 1 minus में n e square upon में m into में omega square epsilon naught. So now see, refractive index of ionosphere, as we know that the refractive index is equal to what? Refractive speed of light in vacuum with respect to the speed of light in that medium. So n equal to c by v, and this c is equal to what? 1 upon में under root of epsilon naught by this one, and this v is equal to 1 upon में under root of mu into में epsilon. So just put this value here, you will get this refractive index is equal to under root of epsilon r into में mu r. Now on just putting this value, mu, as we know that the mu r is equal to 1, so mu is can be equal to this one. So n refractive index is equal to under root of epsilon r, and this epsilon r is equal to 1 minus में n into में e square upon में m into में omega naught square upon में epsilon naught. Now just put the value of epsilon naught here, that is equal to 8.854 multiplied 10 minus 12, m is equal to 9.1 multiplied 10 minus 31, and e is equal to 1.6 into 10 minus 19. On putting these two values, you will get the refractive index of ionosphere, that is equal to n is equal to under root of 1 minus में 81 n upon में f square. Now you will see, observe that the refractive index of ionosphere depends upon the electron density, and this electron density varies in ionosphere layer. It means there are number of sub layers in the ionosphere layer. So you will see here that this refractive index of ionosphere layer depends on what? Depends on number of free electrons and frequency. Clear? So this is the mainly concept behind the mechanism wave propagation in the ionosphere. This topic we will discuss in the next lecture, how the wave propagate through the ionosphere layer. The PPT which I have prepared from these slides, that is the reference for these slides, that is the antennas for the all application by the JD Cross. The book which I have referred for preparing these slides, that is antennas for all application by JD Cross, and the antenna theory analysis and design by the Balanis, and another book that is from the Shubham publication, that is from the antenna and wave propagation. Thank you.